Hello everyone, hello Science Alliance, it is Lara from Theatre of Science, you are the Science Alliance. It's nearly the end of the Forces and Motion module of IGCSE. We've got this lesson on centre of mass, and then one more lesson on adding up vectors, because Christmassy, and then that'll be the end. And next term we're doing electricity, the second module. It's all very exciting. So centre of mass, one of my favourite topics, because it just relates so much to real life. So I've asked you a question here, which I'll put you back to. Two glasses made of the same kind of glass, the same thickness, it's the same drink in both. Which one of these glasses am I more likely to give my 3-year-old, and why? So one glass is, right, it's just a glass, isn't it? It's a normal glass. It's just a glass shape. I'm sorry, you'll just have to take my word for it. And the other glass is more kind of cocktail glass, so on a long stem with most of the glass at the top. One of those I would definitely prefer to give my 3-year-old, wouldn't I? But why? That's the tricky bit. Why? Seems obvious. This is just the best way to learn physics, is to just think about why, and then you realise you actually don't know. So why? We'll come back to that in a bit. Right. So today's lesson is centre of mass. What is the centre of mass? It's so much easier to show it than it is to describe centre of mass. But I did look up definition of centre of mass on the internet, and just the first page of Google had 4 different definitions. I thought it's worth taking 20 seconds just to read these through. How much of this do you understand? Does it give you any idea of what centre of mass actually is? So BBC Bite Size, God bless it, says centre of mass is described like this. The weight of an object may be thought of as acting at a single point called its centre of mass. Byjuice.com, whatever that is, says that centre of mass is a point at the centre of the distribution of mass in space. Oxford Reference, never heard of, says centre of mass is the point at which the whole mass of a body may be considered to be concentrated. And Hyperphysics, which I usually really love but is deeply confusing, says that centre of mass is the unique point in an object or system which can be used to describe the system's response to external forces. Basically, centre of mass it's like the balance point. So I regretted doing this yesterday because it's actually harder than you think. But if you've got a pen or a pencil on you, try and balance it on your finger. I'm just using 2 fingers because I give up. The centre of mass of this pen is somewhere where the pen is balancing on my fingers, right? So sort of in the middle. The centre of mass of a symmetrical object, excuse me, is basically always in the centre. So if I showed you, here we go. If I showed you this bit of paper and I said, can you put your finger on the centre of mass of this paper, you would certainly put your finger in the middle, right? Because you know that there's the same amount of mass on one side as there is on the other side, yeah? And so it's also where the thing balances, okay? So, I don't know, I actually like the Byjuice definition, although I don't know it. The point at the centre of the distribution of mass in space, maybe BBC Bite Size. The weight of an object may be thought of acting as a single point. So it's like this pen is sort of, if you were going to work out the movements of this pen or do some physics to predict how this pen is going to behave when you add forces to it, that's quite complicated. It's simpler to just think about its centre of mass. The centre of mass of this pen is like a point where you could imagine that all the mass of the pen is concentrated and it'll still behave in the same way, if you know what I mean. So instead of thinking about how the pen behaves, you could think about how a tiny little dot with the same mass of the pen behaves, and that would allow you to do the equation. I'll give you some questions and it'll all become clear. I feel like you're getting it, even though I'm describing it very poorly. Here's a sheet for you. Where's the centre of mass? You've got 8 objects here, and I just want you to tell me roughly where the centre of mass is. If you have been to my Facebook group and you have printed out this sheet, you mark it with a cross. So the first object is a spanner. Where's the centre of mass in a spanner? Where's the centre of mass in a ball? Where's the centre of mass in Janet, the dog who we met last week? She's got a sort of big furry bit of fur around her neck and a body and a short stumpy tail. A ring donut, where's the centre of mass on that? A balance. I had to think about this one. So a balance is in physics what you might call like weighing scales. So you've got 2 kind of sacks on either side of this kind of tipping point pivot thing. Where's the centre of mass of that? Number 6 is a book. Number 7, where's the centre of mass on a double-decker bus? Where's the centre of mass of a high chair? And then B, this is important, do this if you're going to do the activity in a sec, draw a non-symmetrical shape on a piece of paper and cut it out. How could you find the centre of mass of that? Using the materials you brought to this lesson. So using Play-Doh, a pin or a needle, some string, a cereal box. How are you going to find the centre of mass of that unsymmetrical piece of paper? Oh, excuse me. And question C, if you've got that far. You've got a high chair and a double-decker bus. How does the centre of mass of the high chair change when a baby sits in it? And how does the centre of mass of the bus change when there are people on it? Does this present problems? So hopefully you've got that the centre of mass is like, on average, where all the mass of an object is concentrated, okay? You're probably fine with this. I'm going to give you one more example because I'm worried that I haven't explained it very well. Are you doing that? Are you all on the second activity? It's surprisingly difficult to cut out a non-symmetrical piece of paper if you're thinking about it. Okay, I'll flip you around. I'll just give you one more really obvious example, just in case any of you are in any doubt, and then we'll go through the answers. So be cutting out your piece of paper if you haven't already. Yeah, so the centre of mass is like, on average, where all the mass of a thing is concentrated. So for example, this spoon, you can see that this spoony end of the spoon, there's probably going to be more mass there, right, than there is just in the handle. So I wouldn't want to put my finger to balance the spoon right in the centre of the spoon because it would tip towards the spoony end because there's more mass there. I'd have to move my finger ever slightly along. Oh, in fact, quite a long way along. Okay, so I'm now balancing a spoon, but obviously I haven't put my finger right in the centre of the handle because that's not the centre of mass. The centre of mass is a little bit further towards the spoony end because there's on average the same amount of mass on either side. Okay, I mean, I know that you're getting it. I just want to really make sure that you've got it. This knife, on the cutty bit of the knife, there's actually slightly less metal, isn't there? There's less mass. So the centre of mass of this knife is going to be further towards the handle end. There. I know that you've got it. Let's go through the answers. The centre of mass of a spanner is in the centre of the spanner. Right, just the handle. It's a symmetrical object, nice and easy. Same with the ball. It's a symmetrical object, so the centre of mass is in the centre. Janet, I don't know. Janet's got some stuff going on. She's got this big furry bit around her neck, but that's not actually going to be very massive, is it? I don't think. It's just hair, not bone. So maybe a little bit further back than you might think on Janet. The donut's the one I really wanted you to think about because the centre of mass of the donut is in the centre. Yeah, it's a bit weird, the idea that the centre of mass of an object might be not actually where it has any mass, but obviously the donut is symmetrical and the centre of mass is in the centre. It doesn't have to be where there's actually any stuff. This balance, this one sort of, I was a bit, I don't know. If the balance is stood upright on a table, obviously it depends what's actually in the weighing scale bits, doesn't it, in these little sacks. I guess you would say that the centre of mass is probably sort of in the middle, but then I was like, well, if I turn the balance around, are these sacks going to fall down on the side? And if they do, the centre of mass would obviously be much closer to that end. But if they stay in place, which I decided they did, the centre of mass would be in the middle. It's not always as easy to think. A book is just in the middle. A double-decker bus. You would think the centre of mass would be in the centre, but it's not actually. They put the engine quite low down in the bus so that on average its centre of mass is lower for reasons which we will discuss at the end. Centre of mass of a high chair, I don't know, I'm not a carpenter. There's wood on the top, there's wood on the bottom, so I'm figuring it's in the middle. Hopefully you've drawn out a non-symmetrical shape now. How does the centre of mass of the high chair change when a baby sits in it and the bus? Well, the centre of mass of a high chair, the baby's obviously more sitting in the top bit of the high chair, so on average there's more mass above the table of the high chair, so the centre of mass would move upwards. And the same on the bus, right? If there's a lot of people sitting on the top deck of a bus, then the centre of mass of the bus would move up as well. Okay. So we need to do something which isn't particularly useful for our learning. It's just a really annoying thing that you have to do. If you brought some cotton or some string with you, you need to tie a little loop in one end of the cotton. I mean, you do an IGCSE, right? How hard can it be? It's just so faffy. Just tie a loop in a piece of cotton. That's what I need you to do. Maybe like fold over a couple of centimetres and then tie a knot, but you just need a loop because you're going to hook it onto a needle in a second, if you've got one with you. So finding the centre of mass of a symmetrical piece of paper. Pretty easy, right? How are you going to do it? Hopefully you're tying a little loop in a piece of string. So while you're doing that, have a think. 10 seconds. How are you going to find the centre of mass of this piece of paper? You can tamper with the paper, that's fine. 8 seconds, 7, 6. It's easy, but it's not obvious at all, actually. 5, 4, 3, 2, 1. Well, the centre of mass is the very centre of the paper. How do you find the very centre of the paper? You fold it once along a line of symmetry. So I've just folded it in half long ways. So we know that the centre of mass is somewhere along this line, yeah? But where? Just fold it along another line of symmetry. This would be such a nice IGCSE question. They won't ask you this. And then where the lines of symmetry cross, that is the centre of your mass, of your symmetrical object. Yeah, it's good, isn't it? It's just a nice little trick. By the way, centre of gravity, centre of mass, it's the same thing, okay? Because obviously gravity is, like, your weight is just how much your mass is being pulled on by gravity. So the kind of on average place where your weight is being pulled, the centre of mass and centre of gravity are the same thing. Okay, let's just leave it at that for now. Right, let's do an activity to work out how you find the centre of mass of a non-symmetrical object. How have you got on with this? Oh yeah, actually just before we do that, I'll show you the setup, because it's probably the faffiest setup we've ever had on Theory of Science, which is not to say that faffy. What I need you to do is get a cereal box like this. You might want to turn it upside down because you need a flat top. Because what I want you to do is sellotape a pin to the top of your box. You see that? I've got my loop of cotton on it already. So this is what, many stages at once, IGCSE, as I'm challenging you. Get a box that has a flat top. I guess you could, no, actually, it kind of needs to be a box. Sellotape a pin to it so that the pin is sticking plenty off over the side. Be careful, it's hard to use pins and watch TV and learn at the same time, so be careful of the pin. And then, actually, you can leave the cotton off it for now. Have your cotton somewhere else. Just be doing that while I talk to you, okay? So, yeah, just to get back to one of the points that one of the definitions of centre of mass was making. So the Hyperphysics website said, the unique point in an object which can be used to describe the system's response to external forces, which sounded really complicated, but actually they make a good point. So, for example, if I was to throw this hammer, I'm not going to, but if I was to throw this hammer and I wanted to think about the physics of how the hammer was going to behave, that would be quite complicated because I'm not good at describing household objects, eh? The hammery bit of the hammer is very heavy. It's much heavier than the back end of the hammer, and it's also heavier than the handle of the hammer. So if I throw this hammer, it's going to spin around, and I don't know, I can't even draw it. The behaviour of the hammer is going to be quite odd. Like, to do equations about, you know, where that hammer might land or how far it might travel, that's going to be hard. But the hammer, where's the centre of mass of this hammer? The front hammery bit is very heavy, the back bit is light, so it's not going to be on the hammer, right? It's not going to be on the handle, which is in the centre. It's going to be just a bit of space, probably under the hammery bit and next to the handle. When I throw this hammer and it rotates, it's going to rotate around its centre of mass, right? So if I plot what the centre of mass is doing on my whiteboard, then that's much easier. It would just be an arc like that. And then the hammer, you could, you know, if it was a proper diagram in your IGCSE paper, you'd see a hammer at all different points, but the hammer would be spinning around its centre of mass. So you can use the centre of mass of an object to do calculations on it instead of the thing. Makes things much easier. Right. Have you set up your pin stuck to the top of a box? And have you got a non-symmetrical shape? I don't know why it looks rude. It's hard. Anyway, what you're going to do is to get any spot on the very edge of your sheet of paper, your non-symmetrical object. It's got to be pretty near the edge, but it can be any point on your paper, and just carefully, all right, because we've had some injuries recently on IGCSE data science, carefully push the paper onto the pin so that your paper is hanging off your pin right next to your box. There we go. And make sure that it's hanging free. It's hanging loose. It should be able to spin. Okay, for reasons that are hopefully obvious, right? Because gravity is pulling your paper down. So the centre of mass is going to be somewhere in a straight line between the needle and the ground. Okay, does that make sense? Like if there was too much friction between the needle and your shape and it was kind of bent like that, you wouldn't be able to find the centre of mass, because you've got to let gravity pull the centre of mass down to like where it naturally wants to be. Okay, now you need your little hook of cotton, and you need to hook that onto your needle as well. Can you start to see what we're doing here? It's good, isn't it? So this cotton is hanging down, and it's kind of drawing out a line on the paper, and we know that the centre of mass must be somewhere on that line, okay? Gravity is pulling this object down, so its centre of mass, its centre of gravity is going to be somewhere in this straight line that the cotton is showing us, between the needle and the ground. I said to bring some Play-Doh, because obviously the cotton's not very heavy, it's looking a bit wiggly, isn't it? So just get a piece of Play-Doh or a piece of blue tack, or I don't know, paper clip, or a younger sibling, and hang it off the end of the cotton to make it a straighter line. You starting to see what we're doing here? Now, a lot of like on the internet, when you look up this activity, a lot of pages on the internet say that you should now get a ruler and draw a line that follows the cotton. I don't think that's a good idea. They don't tend to say to do that in GCSE. I think because it's not going to be very precise. Yeah, you can't get a ruler in there and draw perfectly. What they suggest you do is mark 2 dots or a few dots along the line, and then you can take it off and draw a straight line with a ruler along the dots. So that's what I'm going to do. It's not working because I'm left-handed and I'm having to use my right hand. So push the cotton in so it's right next to your paper, and then draw a couple of dots. And because of something that we talked about in home ed, actually, you need to make sure that your eyes are right in front of the cotton. Yeah, if you're at an angle, you're going to draw your dots in the wrong place. So that's what I'm doing. I'm not ignoring you. This is such a good question, by the way. If you get a question in your IGCSE, like describe how you find the centre of mass of an irregularly shaped object, it's just such a gift because it's always 6 marks, and we'll go through how you get those marks in a minute. All right, so what do I have to do now? Let's take that off and draw the line. So we know that our centre of mass is somewhere along this line. Got a ruler here somewhere. Here we go. Because it's all right doing it, but it's knowing what to say to get the marks. Oh, and of course, this is useful. Your pinprick is also one of the points, isn't it, that your line has got to go through. Don't use a pen like I'm doing. Use a pencil. And don't use a whiteboard to lean on when you're using biro. Just all good lessons for life. Okay, what are we going to do now? You know, don't you? We've got a line that our centre of mass or centre of gravity is on somewhere. To work out exactly where, we need a line that crosses this line. So you've got to do the whole thing again using a different point of your paper. So push any, well, it's actually very hard, isn't it? Push another edge further away onto your bit of paper. And again, just really make sure that it can hang loose. Some of you might be thinking, because it's just occurred to me, what do you do if your centre of mass ends up being a point that isn't actually on your paper? You can't draw your centre of mass, can you? I guess what you'd have to do is draw your lines anyway, and then maybe put it onto a clean piece of paper, put the shape onto a piece of paper and like follow the lines, and then you'd have where it was, if you see what I mean. Anyway, let's get this done. So now we need to ask some questions. So it's difficult, isn't it? Because when you push on the paper, yeah, I don't think that's hanging loose. How we going to test if you found the correct centre of mass? It's not a very difficult question, is it? We've had a lot of clues. How are we going to test if we have the correct centre of mass of our object? In a sec. Oh, I've lost all my dots. Oh, okay, no. So it's got to be going through the pinhole. And then there's my other dots. Yeah, fine. Right. So luckily for me, my centre of mass has ended up on the paper. So I'm just going to put my finger on it, right, and see if the paper balances. Yeah! Come on. Proof if proof were needed. Right, while you're finishing that off, it seems kind of obvious, but I've got the steps that we just did, but they're in the wrong order on the screen, and you have to put them in the right order, please. I've said plumb line because it's just a physics way of saying like blob of stuff on a string. Okay, so a plumb line is, yeah, it's a blob of stuff on a string. The Romans were using them, incredibly useful for measuring things. I think that's all you need to know. Yeah, have a go. What did you just do? Put these in order, please. Find the centre of mass of an irregular object. So the numbers aren't correct, right? So I've put step 1 is place the needle in any other part of the card. Step 2 is place a needle through any part of the card. Step 3, mark dots along the plumb line. Step 4, wait until the card has stopped moving. Step 5, repeat the above steps again. Step 6, hang a plumb line on the needle. Step 7, make sure that the card hangs loose. And step 8, where the 2 lines cross is where the centre of mass is. Can you put those in order for me? Yeah, it seemed kind of obvious, but it's just such a gorgeous 6 marks to have in the bag if you come across this question in IGCSE and you kind of know it off by heart. You know what they're looking for. It's actually quite hard, isn't it? I was like, oh, I better move on. No, wait, I'm trying to do it, and it's tricky. It's so hard. I'm going to reveal the answer in 10 seconds. Okay, here's your answers. Place a needle through any part of the card. Make sure that the card hangs loose. Hang a plumb line on the needle. Wait until the card has stopped moving. That's the kind of thing, isn't it? That is so obvious you'd never write it, but in an exam it would get you a mark. Mark dots along the plumb line. Place the needle in any other part of the card. Repeat the above steps again. And then you draw 2 lines, and where the 2 lines cross is where the centre of mass is. Phew. So there you go. So they might well ask you something like, I don't know, like they might describe how someone has measured the centre of mass of an irregular object and then say, you know, what might they have done wrong or something, and you'd have to say, oh, they didn't wait until the card stopped moving, or they didn't let the card hang loose, that kind of thing. Okay, let's go back to the question that I asked you at the beginning, because we need to talk about stability. I could hear you screaming at the screen, Lara, the cocktail glass is less stable, it's more likely to tip over. Yes, these 2 glasses are kind of identical, except one is less stable, right? One's more likely to tip over. Why is the cocktail glass thing more likely to tip over? Come on, using the words that we've learned today. It's because, there's no reason why I would know this necessarily, this beaker has a lower centre of mass, so it's more stable, okay? The sort of regular beaker, the centre of the average mass of that beaker is probably about in the centre, whereas the cocktail glass, because it's on a long, narrow stem, its centre of mass is much higher. And how stable things are very much depends on where their centre of mass is. It actually depends on something called a line of action. This is where kind of gravity comes in. So, I don't know, what am I going to draw? the only thing I can think of to draw is a fish. Like, it's a bad example. Give me something to draw. A plant. There. Centre of mass of this plant is, well, this is the pot, this is the plant. The plant's very light, so the centre of mass of the pot is probably pretty much the centre of mass, isn't it? The line of action of a thing is just a line that goes from the centre of mass and down to the centre of the earth, basically. It's kind of how gravity is acting on it. It's like its weight, basically, isn't it? It's just a vector, it's an arrow to show its weight. But we call it the line of action. So something tips over when its line of action has gone beyond the base. I have done this in PowerPoint so that I didn't have to draw a series of tipped up plants on the screen. Let's use a double-decker bus. Great example. Here we go. Big tall thing. So there's its centre mass. As we've said, it's deliberately weighted nearer the bottom. And here's the line of action of the bus acting downwards. If you imagine this bus tipping over, then gravity is still working in the same direction, isn't it? So its centre of mass is still in the centre, and gravity is still pulling the bus directly downwards. As long as this line of action lands within the base, this bus will not tip over. So in this case, the line of action is just on the inside of the wheel. So the line of action is within the base, so this bus is not going to tip over. Although I have said, obviously, the situation is not ideal. Do not try this at home. This bus, then, what's happening here? Well, it's tipped over a little bit more, and now the line of action is beyond the wheel. So this bus is going to tip over. It's got a bit dark, this, hasn't it? So you would get an exam question like, explain why people are not allowed to stand upstairs on double-decker buses. And hopefully you're fairly confident about that now. Why are people not allowed to stand upstairs on double-decker buses? But imagine it's an IGCSE question. Have a write the answer. Go on, write the answer to that. Why are people not allowed to stand upstairs on double-decker buses? Use the language that we've learned this lesson. Use the language of physics to explain your reasoning. Let's say it's probably got a 2-mark answer. It's probably 2 marks, isn't it? Why are people not allowed to stand up? Maybe it's well, we'll see. You would definitely get a mark for saying that it would make the centre of mass higher. Don't want to be patronising, please note the spelling of centre, because I'm writing in British English. It would make the centre of mass higher. Oh man, every time. It would make the... Wait. Oh, I know what it is. It's because I'm using the Lego brick that I needed to prop you up for the activity and not the Lego sheet that I need to prop you up for when I'm talking to you. See, it's all very technical. Centre of mass is higher, right? If people are standing up on the bus, then the centre of mass of the bus, on average, there's more mass higher up in the bus, right? So the centre of mass is higher or moves upwards. Therefore, well, I suppose you could put line of action is more likely to fall beyond the base. More likely to fall, to land, more likely to be beyond base if bus tips up. This is a GCSE question, right? So I'm trying to, if bus tips over. Centre of mass will be higher, so the line of action would be more likely to be beyond the base if the bus tipped over. And then, just in case it's an extra mark, I'd put, so less stable. There. I'll show you, just in case this has confused you ever so slightly. And then I'll go back to the answer, don't worry. So our question is, why is it not allowed to stand up on a top deck of a bus? So here we've got a bus. Are we okay with this? So the line of action is just a line going from the centre of mass of the bus to the centre of the earth, right? It's how gravity is acting. So here's the centre of mass again. It's nice and low down. The arrow's gone within the base, so it won't fall over. Here's a situation where the bus has tipped over more. So the line of action is beyond the base. So this bus is going to fall over. So let's do the same bus again, but let's just make the line of action higher. Let's make the centre of mass higher. So this is actually you can't really tell, but this bus is at the same angle as the bus at the beginning that wasn't going to fall over, because if you imagine the centre of mass being lower down, I should have done it on the screen, sorry, that would have been clearer, but if you imagine the centre of mass is lower on the bus, you can imagine that the line of action would be within the wheelbase and it wouldn't fall over. But if there's people standing on the top deck and the centre of mass has moved upwards, then that line of action is now beyond the base and that bus is going to tip over. Disaster. And on that cheerful note, we have reached the end of the lesson. And this is a quick note, while some of you will be liking to copy that down, because how they might try and trick you is, and I've said this before, if you imagine like a bus on a hill, say, this would be a good exam question, I should write to them, and the centre of mass of the bus is here, so it's a bit small, isn't it? It's very small. It would be very tempting to draw the line of action of this bus going like into the hill. But that isn't how gravity works, is it? So if you imagine that this is the ground and this is just a hill, the line of action is not going to be going, because you're used to drawing it just like down from the bus to the ground, right? But if the bus is on a hill, gravity is not working into the centre of the hill. Gravity is still pulling things into the centre of the earth, which is somewhere down here. So just don't let them fool you in that case. That would be a brilliant and evil question. The line of action would be something like that. Okay. Right. That is the end of our IGCSE lesson on centre of mass. One of my favourite ones. There's no maths. It's just like, oh, look at all the stuff around you that you now understand in a more physicsy way. If you're enjoying these lessons, you should totally support me because my Christmas magazine has just arrived. So the only reason that I can do any of these lessons is because most people who watch, I'm amazed at how you don't have to, but you just choose to because you're coming to the lessons and you think it's the right thing to do. Most people are supporting me with £5 or £6 a month. It's still easily like the cheapest way to get lessons that I've come across online. So £5 or £6 a month from most people who watch is plenty enough that I can do these IGCSE lessons and put up homework for them and put up free worksheets and do all ages home ed lessons, which you should come to as well, and even just a fun storytime Lego show. The one tomorrow is on Robins. It's the last one before Christmas. Yeah, so my rule is just I'm just gonna make everything free. I'm not gonna hold anything back from anyone that would help you like learn science or pass your GCSEs. But people who sign up to support me, you need some motivation, don't you? So I've produced Theatre of Science magazine. It usually looks like this, but this is the Christmas issue. It's a bumper issue. So you've got a little craft on the outside. It's like bunting. You make Christmas tree bunting, but there's a little description on each of the trees of like what kind of pine tree it is. And it's got a really massive, it's got the longest comic ever, 12-page comic on the Christmas truce that happened during the First World War and how that relates to Christmas trees and exactly what happened. And it's got a Christmas tree spotting guide where you stand in front of any tree and you answer the questions and you find out if it's a Christmas tree or not. I'm so proud of it. I can't wait to send it to you. Tomorrow is Lego Storytime Day, so that it takes up the whole day and the night. But after that, hopefully I'm going to post it out on Saturday. That's my aim, because Friday's a post strike anyway. Right, I'm on my Facebook page. Apologies for taking so long. Oh, brilliant, some comments. So on my Facebook page is a big post saying, if you're watching live on YouTube and you want to say hello, then say hello. It's Chloe! Hello, Olivia. How are you holding the shape? It looks like a head. Oh, well, that's okay, because that's not rude. Vespa loves my hat and needs one like it. Do you? It got made by my friend, who I think really regretted it after she started it and probably will never make one again. But yeah, it's amazing, isn't it? Like, if you want, just take a screenshot and then ask someone who knits to reproduce it for you. Or start making them, because they would sell well. I'll advertise them for you. Something fell on my whiteboard. Oh, Olivia. Well, at least it wasn't wormy. Brilliant. Olivia C is answering questions. Yay, Olivia, you managed to get it working. And you got your shape cut out. Good. And the bus depends on where people are sat. Yes, it wasn't actually a very good question, was it? Because you're right, people could have been sitting on the bottom. In which case, would the bus have been maybe even more stable? Hello, Phineas and Vesper. Hello, Grace, just Grace. Hello. Right, is that everyone? Brilliant. Grace, Phineas and Vesper, Olivia C, and Olivia P in the same lesson. Excellent. And Chloe. Awesome. Right, thanks for coming, you lot. In 20 minutes, I'm going to be on Facebook, aren't I? hopefully, as long as it's working, in 20 minutes we're going to do the home ed lesson on the immune system, which Phoenix and Vespa have already been to. And Olivia, but are you going to come again? Because the comments on YouTube are really distracting. Right, you lot, like and subscribe and all that. I'll see you both soon. Thank you for coming. Bye.